Today we've got a great panel for you. We're going to be addressing opportunities and risks in open source hardware. In my work, I run into a lot of engineers or engineering organizations that got caught up in the free of Linux, and then they start trying to commercialize it and they realize, oh, this isn't really free. So in that sense, Tim, can you give us sort of a rundown of what building a custom SoC would look like and where there are potential pitfalls and hidden costs?
Well, it's a big question, right? Especially in front of an audience who make a living doing that, right? And I'm sure everyone's aware there's no one answer.
Right.
I mean, I think Rick, I was behind the stage, and looking at it in a mirror image, but I think Rick sort of stole my thunder a little bit with the pie chart of some of the work we've done on a sort of medium complexity SoC, where design cycles can be 18 months, 2 years, depending on whether you're doing grounds up design or whether you're iterating something that already exists. The fully loaded costs when you think about tools and people and compute, IP can run into easily sort of $100 million plus. Right. When we sort of start to break that down, it's no surprise that probably two of the biggest elements of that are verification and software development. They really do tend to suck up the most time and effort and resource. And I think verification in particular is a really complex problem to solve. Again, depending on what you're producing. If you're designing a device that's effectively an open system, anybody's writing software that can go and run on it. There's the verification space is pretty much infinite, and it's not just about does it functionally work. It's does it work in a performant way, and that's not CPU megahertz. That's can you move data around the system? Is it secure? Is it functionally safe? We're moving into a world where more and more of these chips are going into environments where they need to be functionally safe, and all of these are additional costs, design costs as well as verification costs. I think if you sort of contrast that at the lower end, then there's clearly ways of creating silicon for significantly less than the sort of 200 million, 100 million, whatever I was talking about before. And I think that's a really interesting world, and a world where we're definitely involved. For years we've had low-end embedded processors and trying to unlock that capability, and that's where again over the last 2 days and previously I really see that community platforms, mixtures of open standards, open source hardware, software. That's what's going to enable people to create these low-end trillions of devices for sort of very bespoke endpoint applications. And we've been working with a company called eFabless, who for me have a kind of real visionary community platform that brings together developers, designers, IP providers, and enables people to create silicon. And we're talking $50-$60K to create a simple embedded endpoint. So really difficult question to answer, but very much depends where you're headed, what risk you want to take. But these are at the high end, they're long design cycles with big costs.
Very good. I just want to give you an opportunity, Tim, real quick. This isn't to say that ARM does not participate in the open source community at all. That's patently false. So what is the role of open source going to be moving forward, and particularly on the software side, for ARM strategy, for your roadmap?
Yeah, I mean, yes, we do participate in open source, and again, it's quite a difficult position to sit in, with the people here. But yeah, we made huge contributions, right? I think without being too corporate, there's around 1,000 software engineers in ARM contributing to open source projects. We clearly contribute to the open standards that have been talked about today. We've either creating them through things like Amber and our platform security architecture, or through participating in open standards. So that continues. I think it's sort of where you, in a sense, where you draw the line. Around, it comes back to that architectural governance and what fundamentally do you believe is the right model to enable the technology. I think absolutely I see a world where open source hardware will play a part in SoCs, and I think it'll be like open source software world where there'll be a mixture of proprietary and open or open source, and you see that in the RISC-V world, right? Sci-Fi and these guys, they're not open source implementations of the processor. Nobody here has claimed they are, right? But they will appear in chips and alongside open source hardware, and I really believe for this kind of the long tail, this kind of the innovation that's been talked about to create that, it is all about that enabling through community platforms, through collaboration. And I'm not on the payroll, but I'll go back again to people like eFabless who are creating models that really work. They have RISC-V, they have an ARM design on their platform. It's bringing communities together, mixing open source with open, with proprietary, mixing tools, mixing IP. I think these are the models that are going to fuel innovation. At the high end, if you're AWS deploying servers, you're not going to be using these community platforms. But for many people, that world needs to be opened up. So I see that's how ARM will participate and show up, and we'll be there. We'll continue to make contributions.
All right, thank you.